Hello everyone. In this video, today we are going to discuss about the trigonometry. So in this first part, I'm going to discuss the basic terminology and we'll start the trigonometric ratios and compound angles. So let's see what is the meaning of trigonometry. Trigonometry means tri plus gone on plus metry. So here the meaning of tri means three, gone on means angles, metry measurements. So the topic name itself discuss about the three angle measurements means majorly discuss about the properties of triangles. And in many places we can apply this trigonometry. So let's see a few terms basically which we need to know. The very first one is angle. So what is mean by angle definition? So let's see. This is a ray, initial ray. Let us assume initial ray. It's started from O, and this is X, OX ray. So symbolically, we can write like this, OX ray. And I have another ray. So like this, let's think this is OP ray. This is OP. So here OX is initial ray. So with respect to this ray only, we will discuss about the angle. So this is called a rotating ray or revolving ray. Rotating ray or revolving ray. So means it's not fixed. Initially, let's think this OP is coincides with the OX, and slowly it's started rotating, and after some time, after t seconds, let's think this is the position of the OP. See here, this OP ray means that rotating or revolving ray is done some amount of rotation here. So this amount of rotation is called angle. So usually it is denoted with theta, alpha, beta, gamma, and so on. So how can we define this definition wise? The amount of rotation done by a rotating ray or revolving ray with respect to a fixed ray. With respect to a fixed ray is called angle. In this diagram, so from this figure, so in the figure, so how to write that? Generally, that angle can be denoted with the theta, alpha, beta, gamma, or A, B, C, like this, all the capital letters of the alphabets, English alphabets. Or in another way, geometrically, how can we represent the angle is angle XOP or angle POX or angle at O. Means where the angle is forming, that is a vertex. So that vertex should come in the middle when you're naming like this. So that means it indicates that at this point, so the vertex is formed and the angle is formed. So this is the way how can we define the angle in the trigonometry. So angle can be measured. Angle can be measured in different ways. Can be measured in majorly in three ways. Measured in different ways. So we can see generally what we'll use is degrees in different ways. So in that different system, in the first system is sexagesimal system. Sexagesimal system. So which is also called British system. So in the sexagesimal system, angle can be measured in terms of degrees. So generally it is denoted with capital D, and symbolically we'll show like this 1 degree, 2 degrees, and so on, some X degrees or Y degrees. Like this symbolically with a small bubble on above the number top right side, we will keep the bubble and we will denote this and we will read it like 1 degree, 2 degree, so on. So how can we define it actually? So if you take a circle, In this circle can be divided into 360 equal parts. 360 equal parts like this. So 360 equal parts. So 1 by 360th, 1 by 360th part of a complete rotation. 1 by 360 part of a complete rotation of a rotating ray. Of a rotating ray is called degree. Is called degree. So total here we are dividing this circle into 360 equal parts. So each part is a degree. Each part is a degree. So here 360 part is a complete angle. Here 360 part is called 360 degrees is called complete angle. Complete angle. And 180 degrees is called straight angle. Straight angle. And 90 degrees is called right angle, means one right angle. 90 degrees is one right angle. So like this we'll measure it. So 1 degree we can take like 60 minutes. This symbol denotes the minutes. So 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. So this denotes the 60 seconds. So in this way we will take the angle measurement in sexagesimal system. So next system number 2, centesimal system. So next one is centesimal system. So if you look at the figure what we drawn here, so in the sexagesimal system the complete circle is divided into 360 equal parts. So when it comes to this centesimal system, this total circle can be divided into 400 parts, 400 equal parts. So each part is called a grade. So here the angle can be measured in terms of grades. In terms of grades. So 1 by 400th part, 1 by 400th part of a complete revolution, 1 by 400th part of a complete revolution or rotation of a rotating ray is called a grade. So usually how can we denote the grade here? So how can we denote the grade? So like this, with capital G, and symbolically like X grades, 10 grades, 30 grades, like this will with a small g above the number, we will denote the grading system. So here 100 grades is equal to one right angle in this system. They define like 100 grades as one right angle, and one grade is equal to 100 minutes, and 1 minute is equal to 100 seconds. We will take in the grades centesimal system. Next, third system. This is circular system. Circular system, or we can call it as Indian system. So here this centesimal system also called a French system. This is also called a French system. So this circular system is called a Indian system or radian system, or radian system also we can call it as. So we can call it as radian system also. So what is meant by radian here? So let's see the measure of the central angle, subtended by an arc, subtended by an arc of a circle equal to the radius, of the circle. So it is denoted by C, or we can write 1 power C, or simply if you write like this also, you have to think that if nothing is mentioned, it is in radians, simply. So symbolically, I mean with a diagram, so how can we show how can we tell us? So this is circle from the center where took the radius, and one more radius, let's take like this, so from the center of the circle to this. So this is the measure of central angle done by this arc of the circle. So the angle made at the center. So we can take like radians. So there is a good relation between this D, G, and C, which is useful to solve a few problems and converting angles from one system to another system. So that is relation between D, G, and C. So relation between D, G, and C is we can take like D by 90 is equal to G by 100 is equal to C by pi by 2. So in radian system, pi, radians means in degrees it is 180 degrees. So 180 degrees, that will be equal to 200 grades in the centesimal system. So this also we can write like 2c by pi, both are same. So there is a relation between these three. So let's see how can we use this relation. So we have one example here. Express 150 degrees in terms of grades and radians. So see here what they're given. Let's see the solution. They are given in terms of degrees, means D value they are given 150 degrees. D value they are given 150 degrees. So need to find in terms of G, I mean in grades, and C value. This is what we have to find. So what is the relation we have here between these three? D by 90 is equal to G by 100 grades is equal to 2C by pi. So this is the relation we have between these three. So among these three. So first case, I'll find out the G. So for that, I will take relation D by 90 is equal to G by 100. So from here, G can be written as D by 90 into 100. So what is the D value they are given? 150 degrees divided by 90 into 100. So here, these two gets cancelled. 3 3s are here. 3 3s are and 3 5s are. Is that right? So 3 3s are and 3 5s are and 0 50s are. And what we can take more? What we can take more here is 50 into 100. Here is 50 into 100 is nothing. 50 into 10 is 500. 500 divided by 3. 500 divided by 3 means what you will get? So what we will get here? Approximately like 3 ones are 203 6 are 18. 6 is 18.66 like this. We'll get in terms of grades. So next one, D by 90 is equal to 2C by pi. So here C is equal to D by 90 into pi by 2. D by 90 into pi by 2. So that is equal to D is 150 degrees they are given by 90 into pi by 2. So this 0 and 0 cancel. 3 3s are 3 5s are. So we will get it as 5 pi by 6. 5 pi by 6 radian. So this is the way. How can we find out in terms of grades and in terms of radians when they are given in degrees? So let's see one more example. Let's see one more example. So one more example is example number 2. Express 120 grades in terms of degree and radians. So now they are given in terms of grades, means they are given the capital G value, that is 120 grades. We need to find in terms of D and in terms of C. So relation is same. D by 90 is equal to G by 100 is equal to 2C by pi. 2C by pi. So here the first case is D by 90 is equal to G by 100. So here D is equal to G by 100 into 90. So that means G value they are given here 120. 120 by 100 into 90. So here 10 and 10 cancel. These two zeros cancel. So we'll get 108 degrees. So therefore, D value we will get 108 degrees. Means 108 degrees is equal to here 120 grades. So next, second one, G by 100 is equal to 2C by pi. So here C value is G by 100 into pi by 2 will get. G is how much they are given? 120 they are given by 100 into pi by 2. So this 0 and this 0 is cancelled. So 2 6 2 5 2 1 and 2 3 will get. So 3 pi by 5 radians. So hope you got the clarity based on these two examples. So whichever they will give, we can use this common relation and we can solve the problem. We can convert the angle into one system to another system. So there is one important note here that is, if theta be the angle, subtended by an arc of length L on a circle of radius R at its center, then length of the arc, how can you find? Length of arc is L is equal to R theta. So L is equal to R theta. So diagrammatically, what they're asking, let's see. So this is a circle, and they are told that this is given radius R, and that is what R is, and from here to here, this length they are given L. So how can we find this L? When this arc made an angle theta at the center, then how can we find the length is in this way? And what about this area? How can we find the area of this sector? So this is called a minor sector because it is lesser than the semicircle, and the remaining portion, what we have, this portion, this is called a major sector. This portion, complete portion, is called a major sector. This portion is called major sector. So please remember this, because when the situation came, I'm explaining this. So this is called major sector. So here this arc made a minor sector. So how can we find the area of sector? How can we find the area of sector is half of L into R. So what is the L here? R square theta, R theta into R. So that means A, if you denote area with A, half R square theta is the area of sector. So this is the way how we will find out length of an arc and area of sector done by that arc. So this is the basic terminology. So a few more things. What we have here is, what is meant by angles in standard position? Angle in standard position. What is meant by angle in standard position? So let's see. So angle in standard position in the sense, so if I take coordinate system, means y-axis and x-axis like this, the angle made by a ray at the origin, the angle made by a ray at the origin is called angle in standard position. Angle in standard position. Standard position. So this ray is called a terminal ray. This is called a terminal ray. So hope you understand what is meant by angle in standard position. So next, I will write the definition here. If the angle, simply I will write the definition to understand that if the angle made at the origin, if the angle made at the origin is called angle in standard position. Angle in standard position. So this is the way how can we define in simplest way to remember. So what is mean by coterminal angles? What is mean by coterminal angles? So here coterminal angle in the sense, if two or more angles have the same terminal, so means here this angle and this angle, so both are having the same terminal, so those are called coterminal angles. Means if two or more angles, if two or more angles have the same terminal side, have the same terminal side in standard position. In standard position, this is important. In standard position, then they are called coterminal angles. Then they are called coterminal angles. Coterminal angles. So we have some more terms to define. So what is meant by allied angles? What is meant by allied angles? Allied angles. So in simplest way, how can we say this? Two angles are said to be allied angles if their sum or difference is either 0 or a multiple of 90. Two angles are called allied angles when their sum or difference is either 0 or a multiple of 90, or we can say pi by 2. Then they are called allied angles. That is nothing but, if I assume x and y are two angles, so then if they are satisfying mod of x plus y is equal to 0 or n pi by 2, where n belongs to natural numbers only. So then we can say this x and y are allied angles. Allied angles. So hope you understand what is meant by allied angles. So next, what is meant by complementary angles? Complementary angles. So what is meant by complementary angles? So here two angles are said to be complementary angles. Complementary angles if their sum is 90 degrees. If their sum is 90 degrees. That means if I take two angles as x and y, so x plus y is if 90 degrees, then these two angles are called complementary angles. These two angles are called complementary angles. Simple example like 20 degrees and 70 degrees, 30, 60, so like this, or 40 and 50. So these are all called complementary angles. So what is meant by supplementary angles? What is meant by supplementary angles. So here supplementary angles in the sense, complementary angles means sum is 90. Complementary angles means sum is 180. Two angles is said to be, how can we define this? Two angles are said to be, two angles are said to be supplementary angles. Two angles are said to be supplementary angles if their sum is 180 degrees. If their sum is 180 degrees. So for example, 20 degrees and 160 degrees. You will add these two, we'll get 180 degrees. Or 30, 150, 110, 70. Like this, we can take the many examples whose summation is 180 degrees. So these are the basic terminology, minimum what we have to know to understand the trigonometry. So let's see now trigonometric ratios. Trigonometric ratios. So each and every point is important in the trigonometry. Each and every term is important. So how can we define the trigonometric ratios? So let's take a circle. First of all, coordinate axis, let's take, this is y-axis and this is x-axis. This is x-axis. Let's take the circle whose center is origin. So that means let's take like this. And there will be a point, let's take on the circumference of the circle, let's think px, y. So it means that, so this point P, what we took the point P is having x distance on the x-axis and y distance on the y-axis. Means from P to x-axis, if I'll draw one perpendicular. So let's think this PM is mod y. So this is mod y. Since it is, they're taking like distance. So now how, let's think this OP lines beta ray is making an angle theta with the positive direction of x-axis. So how can we consider the angle is? Angle can be considered in positive if the angle measured in anti-clockwise direction. And it will be taken negative if it is measured in clockwise direction. So now how can we define the trigonometric ratios here? So let's see first one. Opposite to side, opposite side to theta. We can write in the opposite side to theta by hypotenuse. So this OPM in triangle OPM, so it is a right angle triangle. So this is called hypotenuse. And the side, this is always hypotenuse, means which is opposite to right angle, and which is opposite to our angle is opposite side, which is adjacent to our angle is adjacent side. So how can we define opposite side to theta by hypotenuse? We given one name, sin theta. This shortly we can write sin theta. Here sin theta is not multiplication of sin into theta. This is wrong. So sin theta is completely one term. So when theta we will write, then only there will be one meaning for that one. So opposite side to theta by hypotenuse is named as sin theta. The original name for that is SINE, sin theta. So in short form we can call it as a sin, SIN. So next ratio is adjacent side to theta by hypotenuse is named as cos theta, which is also called cosine theta. So cosine theta. So this is simply named as cos theta. And the third one, opposite side to theta by adjacent side to theta. This is named as tan theta. This is named as tan theta. And if you'll observe carefully, if I divide this numerator and denominator with a hypotenuse, so then it will become opposite side to theta by hypotenuse by adjacent side to theta by hypotenuse, which we can write like sine theta by cos theta. That means tan theta is written like sine theta by cos theta. So we have to remember this. So these three are called basic trigonometric ratios. Basic trigonometric ratios. So we have another trigonometric ratios which are reciprocal of these trigonometric ratios. So in that first one is, fourth one, cosecant theta. Cosecant theta is reciprocal of 1 by, sine theta, reciprocal of sine theta, which can be written as 1 by opposite side to theta by hypotenuse. That can be written as hypotenuse by opposite side shortly. So cosecant theta is taken as hypotenuse by opposite. So in the similar way, we can take secant theta. Secant theta is 1 by cos theta. So which also can be written as 1 by adjacent side to theta by hypotenuse, which can be written as hypotenuse by adjacent. So that is, we can write secant theta as hypotenuse by adjacent side to theta. So in another way, so here, this, how can we write this? Cosecant theta is equal to 1 by sine theta. We are getting, that means cosecant theta into sine theta. So this sine theta, when I will multiply this side, cosecant theta into sine theta is equal to 1, since they are reciprocals. And similarly, here secant theta, we know 1 by cos theta. So when we will multiply cos theta to this side, we will get secant theta into cos theta is equal to 1. So this is the way how to do it. So next, sixth one. So what is the sixth one is cot theta. Cot theta is reciprocal of tan theta. So which can be written as 1 by opposite by adjacent to side to theta. So it can be written as adjacent by opposite. So that is, therefore we can write cot theta is equal to adjacent side to theta by opposite side to theta. So here, in the same way, from here, how can we write this one is cot theta into tan theta is equal to 1. So we have to remember these all relations to solve. So this, see, little bit if we'll discuss here, this is opposite side to theta means mod of y by r. This is mod x by r. So this can be taken as mod y by mod x. So like that we will take. So remaining all are just reciprocal of this. So hope you understand how can we define the trigonometric ratios, TRs. Shortly we can call it as TRs. Next, trigonometric values. Trigonometric values. Trigonometric values. So how can we take the trigonometric values? Let's see. So let's we try to take a tabular form. So how many we need? 6 by 7. 6 by 7 tabular form we need. 6 by 7 tabular form we need. Okay. So let's see here. 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. So let's try to increase the this will take, sorry, yeah, so 90 degrees. So here this side will take sine theta, cos theta, tan theta, cosecant theta, secant theta, cot theta. So sine 0 is 0, sine 30 is 1 by 2, sine 45 is 1 by root 2. So sine 60 is root 3 by 2, sine 90 is 1. So how to remember this is, it's to start with 0, right? 0, 1, 2, 3, 4. So highest number is 4. So divide everything by 4 and take the square root of this one. Square root of this one. So you'll get like 0, 1 by 2, 1 by root 2, root 3 by 2, 1. So these are the values here we took. So cos theta is just reverse of this one, means it is 1 root 3 by 2, 1 by root 2, 1 by 2, and 0. So tan is sine by cos. So 0, 1 by root 3, 1 root 3, infinity, which will take as not defined. So remaining 3 we can calculate as usual. So this is a way. And in the next videos, we will discuss how these trigonometric ratios values we got. So we'll discuss the proofs of this one at the end of this chapter. Right now, not required. So these are the trigonometric values, how we will take. Next, the sign of the ratios in each quadrant. The sign of the ratios in each quadrant. The sign of the ratios. The sign of the ratios in each quadrant. In each quadrant. So this generally our regular teachers will tell that all silver teacups formula. All silver teacups means in every quadrant the first letter denotes the which trigonometric ratio should be positive. Generally this we will discuss now. We will discuss. Generally the first letter denotes the basic trigonometric ratio. Basic trigonometric ratio. So let's see, take the coordinate system, and this is divided into 4 parts. So this is quadrant 1, which is x-axis, positive x-axis and positive axis. This is the origin. And the negative x-axis, positive axis is quadrant 2. And this is quadrant 3. And this is quadrant 4. So let's start from here. So all silver T cups. So that means all means here all trigonometric ratios are positive in this quadrant 1. So means what here, what you will get if you start from 0 here. So 0 to 90. So here in this quadrant means 90 less than 90 means 90 minus theta. So here theta will be less than 90, greater than 0 degrees. So symbolically, how can we write this one is 90 degrees minus theta belongs to this quadrant. So if I'll go to this, cross this y-axis, so this will become 90 plus theta, 90 plus theta, and this is lesser than the 180, right? So 180 minus theta. So which trigonometric ratios are positive here? So yes, yes means sine, basic trigonometric ratio. So sine theta and its reciprocal, cosecant theta, these two are positive. And the remaining 4 means cos theta, its reciprocal, secant theta, tan theta, its reciprocal, cot theta. These 4 are negative in this quadrant. So comes to the third quadrant, T. T means tan, tan. So here, tan, its reciprocal, cot. These 2 are positive. Remaining 4 means sin theta and its reciprocal, cosecant theta, cos theta, its reciprocal, secant theta. These 4 are negative in this quadrant. And which angles comes in this quadrant is, this crosses means it is 180 plus theta, and less than 270 means 270 minus theta. So here in this, theta lies between 90, greater than 90 and less than 180. So here in this, theta is less than 270, greater than 180. So this is one. Comes to the fourth quadrant, C. C means cos. Cos and its reciprocal, secant theta. These are positive, and remaining all are means sin theta, cosecant theta, tan theta, and cot theta. These are negative in this fourth quadrant. So, which kind of angles we will take here? Greater than 270, that means that 270 degrees less than theta, less than 360. It lies between 270 and 360. So that means 270 degrees plus theta and 360 degrees minus theta. So if the angle completed one rotation, if you want to proceed again, greater than this means 360 plus theta. So like this, we will take the angles in each quadrant and we will discuss the sign of the each trigonometric ratios. So let's just see a small example. How can we discuss this one is? For example, I want to find out the sine 120 degrees. Example, if I want to find out sine 120 degrees. Okay, so I know only 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. Here, one thing we have to discuss is this 0 degrees, 90, 180, 270, and 360. These are called quadrant angles. These are called quadrant angles. So, this 120, we have to convert into nearest quadrant angle. So here, 90 and 270 are called odd angles. 90 and 270 are called odd angles. 180 and 360 are called even angles, not numbers. Odd angles and even angles. So before discussing this question, well, let's know if odd angles comes, then sin theta will be changed as cos theta, and cos theta ratio will be changed as sin. Tan will be changed as cot, and cot will be changed as tan. And secant will be changed as cosecant, and cosecant will be changed as secant. So when odd angles comes, when even angles comes, here odd angles means 90 plus r minus theta, or 270 minus plus r theta. Even angles comes, there is no change. Sin theta will be sin theta only, cos theta will be cos theta only, tan theta will be tan theta, like that. So here even angles means when comes 180 plus or minus theta, or 360 plus or minus theta. So let's see. Sin 120 degrees. So how can we write? So in most of the cases, we have to change the angle to the nearest to even angle only. Then there will be no confusion. So if by mistakenly, when you are taking odd angles conversation, and if you forgot to change sine as the cos or tan as the cot, then your answer will get changed. So it's better to change always to the nearest even angle, nearest even quadrant angle. If I'll say for 90, for 180, sorry, 120, 90 and 180 are nearest quadrant angles. But I will not prefer 90 degrees, because if I take 90 here, I have to change sine to the cos. So that's why I will take as well always the easiest one, that how can we write 120 in terms of 180? So from 180, if I'll subtract the 60, I will get 120 degrees. From 180, if I'll subtract the 60, I'll get 120 degrees. So the sine 120, I can write like 180 minus 60. 180 minus 60. Now let's we check. Just by assuming this 60 degrees as the theta, so it will become sine 180 minus theta. So 180 minus theta belongs to which quadrant? So look at this. So 180 minus theta belongs to which quadrant? So it belongs to second quadrant. In second quadrant, sine is positive or negative. If you look at sine is positive. So whatever you are going to get the answer for this question, that is positive. And since 180 is even angle, we will not change the system. So sine 180 minus theta will become sine theta only. So that means theta here is 60 degrees. So sine 60 is, we know that root 3 by 2. So here 180 minus theta is belongs to Q2. So this is the way how we can solve the different angles by using the all silver teacups. Let's see another question. Tan 135 degrees. Let's see tan 135 degrees. So how nearest angles are, we know 90 and 180, but I will prefer 180 only, I told you. So we can write 135 as 180 minus 45. So let us assume this is theta, then it will become tan 180 minus theta. Then it will become tan 180 minus theta. So 180 minus theta, just now we saw it belongs to Q2. In Q2, tan is positive or negative. So if you look at this one, tan is negative. So tan 180 minus theta, you will get negative value. So that's why tan 180 minus theta, we can take minus tan theta. So this 180 will be removed, only will take minus tan theta. Here theta is 45 degrees. So tan 45 degrees is equal to minus 1. So tan 45 is 1. So we have negative value in front of that. So it will be minus 1. So let's see one more question. So that is third one. Cos 150. Cos 150 degrees. So how can we write? Cos 180 minus theta. Cos 180 minus theta. This is also belongs to Q2 only. So cos is negative. So minus cos theta. So this is 180 minus 30 we can write. So which can be minus cos theta. That means minus cos 30 degrees. So we'll get minus root 3 by 2. So more than this, one more thing we will take, like 210. So tan 210 degrees, or we can take cosecant 315 degrees. So let's see these two examples, and we'll complete this topic. So tan 210, how can we write? Tan 180 plus 30. So 180 plus 30, this belongs to in terms of 180 plus theta, it belongs to Q3. In quadrant 3, tan is positive. So since it is even angle, tan will be like tan only. So tan 30 degrees. Tan 30 is 1 by root 3. So next, this one. If you'll see the solution for this one, cosecant 315 can be written as cosecant 360 minus 45 degrees. I'll assume this is theta. So 360 minus theta belongs to quadrant 4. In quadrant 4, cosecant theta is negative. Just look at cosecant theta in the fourth quadrant. See here. So cosecant theta is negative. Cosecant theta is negative here. Cosecant theta is negative. So cosecant theta is negative. So what will get the answer here? So negative means minus cosecant 45 degrees. Since it is 360 also even angle, so we cannot change the cosecant. Cosecant will be like cosecant only. So minus 1 by cosecant 45 is root 2. So minus root 2 will be the answer. So there is another way to solve the same questions. So how means, see here, this is the another way. How can we solve this question number 2? Even tan 135, I can write like tan 90 plus 45 also. 90 plus 45. So 90 plus 45 we can write. So when we'll write 90 plus 45, when we can write 90 plus 45. So here, this is odd angle. This is odd angle. So tan will be changed as cot. And 90 plus theta belongs to second quadrant. So in the second quadrant, tan is negative. So minus cot 45 degrees. So that is minus. See, the final answer will be same only, but the way we can solve, when we'll take the odd angles, so the trigonometric ratio should be changed to its reciprocal ratio. So this is the way how can we solve. So you can try the remaining all. in the different ways. So here I'll solve one question based on this. One question we are going to solve. So that question is uh, cos 10 degrees. Find the value of cos 10 plus cos 20 plus cos 30 plus cos 80 plus cos 80 plus cos 100 plus cos 150 plus cos 160 plus cos 170. So find the value of this one. Find value of this one. So if you look at this, how can we write it? This 4, no change. Don't change this one. So cos 10 degrees plus cos 20 plus cos 30 plus cos 80. So there will be no change. If you observe this 100, I can write 180 minus 80.